Alright guys, in this video we will talk about event sourcing. So event sourcing is a computer architecture design pattern, you can say, and it is used for storage of things. So let's talk about how do we traditionally store something first. So let's say that we are building some e-commerce site, which is pretty common, selling something. We have some items, customers, their orders, their shipping info, and we use a traditional database like SQL, and we store the different objects here as tables in the database. So the order would be an order table, item would go in item table, each row would be some kind of a transaction or a particular instance of an order. And what you know is only the end state. So once an order is placed, whatever is the last state of the order, that's what would be recorded as the transaction, that row. You could store multiple rows trying to indicate what happened along the way if you needed for some reason. But for the most part, order might have a state, say pending, completed, and all you know is that the order was completed. You don't know how the order went from which state to another, and so on. Now, event sourcing model allows us to keep track of things like that. It saves all of the actual events, and then it aggregates the objects on the fly or in memory, and it effectively saves all of the object states. It enables us to do things like time travel, so figure out the state at any point of time. And it also allows us to have an audit trail. For example, if a customer's money was refunded or another new item was sent, or perhaps it first failed but then it succeeded later, and so on. So now, what we have here is a list of things that might happen. For example, an inventory item was added, a customer browsed an item, a customer added the item to the cart, and then they added some payment details and checked out that cart, and that item was then shipped to a customer. Now, if you're thinking in terms of objects, one of the objects that we considered is the item. And all of these events, whether the item was browsed or item inventory was added, or customer added an item to the cart, or even internal things that happen, internal events that happen in the system, anything that impacts the item object, right? All of those events can kind of be put together as what we can, using an item key, which would be the item ID, and we can call that the item aggregate. So in event sourcing, what we do is we group the events based on the aggregates that we're trying to create. So if we were trying to, for example, track an order object, we would essentially track all the events that occur that could potentially change or update the order object in any way. So let's look at an example of that. So let's skip here and look at an example of that. So an example here could be two pants are added to a cart, one t-shirt is added to a cart, one pant is removed from the cart, a hat is added to a cart, and user checked out. So all of these could impact the cart aggregate. And here you can see step 3, which says summarize, is essentially showing us what is finally in the cart for that given customer. So there's one pant left, one t-shirt, and one hat. And so what's happening here is that some events are coming through, like customers adding and removing things from the cart, checking out. And then the summary is basically the cart aggregate here. Now we can separate that, and we can then write that in a database and query that aggregate, right? And These event queues can come from something called CQRS, which we'll actually talk about a little bit later in the presentation. They can come as events from certain kind of sensors. For example, if you have Ring cameras for security and then camera images are coming through in a queue as a stream, and you're detecting persons or mail packages in those camera sequences. So that could be a queue, which is coming through not from necessarily a REST API or from a SOAP API, but maybe from a sensor. A queue can also come in from another server or another system in your organization. A queue can be created through an API as well, which is the case with CQRS, which we'll talk about later. So event queues can happen in multiple ways. That's the second step. And the third step, which is the summarizing into an aggregate, that can also happen in multiple ways. For example, one way to create the summary table would be just to play back through all of the events that have occurred. And so you would play each event and then keep trying to come up with what that summary looks like. Another way to summarize would be to create a publisher subscriber model where all of the events are published to a queue, and you create a piece of code which is subscribing to that queue and keeps updating the summary table from that subscription. So that's another way to create the summary table. So in the event sourcing model, we might save the event log for the aggregate type, whichever way the event queue is coming through, and creating our event log. We can define an initial aggregate for the thing or the object that we are trying to track, for example, a given item or a given cart, as we saw in the example we just did. And then every time actions happen, we can, as you can see in this code example at the top, we have apply methods. So you might apply to the current state that, a product was shipped, so update the quantity. A product was received, so update the quantity. Maybe a customer support or customer service person manually went in and adjusted the quantity after checking the warehouse. And so apply that, inventory adjusted, and so on. So you can apply actions to keep updating the summary table. And at the end of it, you're saving those summaries somewhere in a database. It could be a traditional SQL database or some other kind of database, NoSQL. But basically, you have a projection that a read system which just wants to know how much inventory do we have, maybe create a dashboard or something, can use those projections and join things or query those projections to figure out how much inventory we have. Now, like I said, there's subscribing to the events in a publisher subscriber model to create that projection. But another way is playing through those events and saying, okay, I'll start each time from event 1 and play through all of those events and figure out what is my final projection look like. And for that, there are different types of databases. Some databases, like columnar databases like Vertica or DynamoDB, have very fast reading capabilities, and those are the ones where you would be able to quickly play through all of the events to compute your projections. Now, you might have a system which has slow reading, and in that case, you might want to cache the intermediate steps in order to aggregate to the last step quickly and figure out your final projection. So, for example, or if you had very large sequences of actions to play through to figure out what is the final state. So in that case, a snapshot is basically keeping state at different points, and you could mark it and basically say, okay, this is where I took the last snapshot, and here's the 10 events that have happened after that snapshot. So to get to the current state, I'm going to start from the snapshot and play through the remaining, the last part of the sequence of events that I have. So that's the idea behind building your event sourcing model. So now that we have built some kind of an event sourcing model, and the advantage clearly being that you can, create a time lapse or something like that, let's talk about the next interesting concept here, which is often used along with the event sourcing model, which is called command and query responsibility segregation, CQRS. And this is different from CRUD in the sense that you are not just combining the reading and updating and deleting all in one system. You're kind of creating two parallel architectures, one for updating things and one for reading things. And this can be good for security purposes to ensure that only certain groups or roles can update a system. It can be good for things for scalability, where you're separating your databases from which you read and from databases into which you can write, and things like that. So the top row here in the diagram shows you a way to update, and the bottom row in the diagram shows you a way to read. So the client, if he's trying to update, would give a command. It could be through a REST API, and that would then be handled by a controller or some kind of a command handler. We will talk about what a domain model is afterwards, but for now you don't have to worry about it. So you can give a command, and that command can just go in and create an event. So for example, my command might be add 2 pants to the cart. And so adding 2 pants to the cart and the number, that would be the event. And I would save it that the customer X tried to add 2 pants to the event, and then move it, publish it to the event handler, from which a system could subscribe and write it to the query database, the summarization. And then on the read side, somebody can query and say how many pants are in the system, and from the query database pull out how many pants are in the system. So in this way, we have separated the collecting of all of the events into the event store, and we have collected all the summary tables in our query database. And so that's what the CQRS is doing by separating these two systems. Next, let's talk about how this might happen in a larger microservices kind of system. So here you have 2 different microservices. One is an order microservice, one's a customer microservice. Both microservices have a separate command service and a query service. So the query service basically reads from storage the summary tables like we mentioned. And those summary tables are built from some kind of a queue. So in this case, you can see the order microservice read storage is reading from this event consumer code, which is all coming through this messaging system, which is essentially our queue. It could be something like a Kafka queue or something of that sort. So basically all of the events are being written onto the messaging system. Events are being read from the messaging system. That's our pub/sub model there. The read storages are summarizing all our tables, and event stores are keeping all of our events as they happen using the command service. Same thing is going on in the event store, which is another microservice for the customer microservice, is doing the same thing and keeping customer events on it. Okay. And then users are basically calling their command endpoints versus their query endpoints for writing and reading data. Okay. So this is how you might do a microservice architecture with multiple microservices and event sourcing with CQRS. The query endpoints can essentially look like your regular REST endpoints. Command endpoints can also look like your regular REST endpoints, or they could be SOAP endpoints, gRPC. Okay, so I promised earlier that we will get to domain modeling a little bit later in our talk here. So domain modeling is basically based on things that domain experts might say. So a user has been registered, an order has been received, a payment deadline has been expired. A domain expert is basically defined as somebody who knows the business logic around whatever events and things are happening. And how would the business person talk about what is happening in the system? So that's basically domain modeling. It's different from event sourcing in that event sourcing is just the state management, and it can be at a technical level. You might be managing, okay, you know, the order has been updated, it's pending, it's this, it's that. And there can be a lot of system level or technical level updates and reads and writes. But if you're doing things modeling things at a domain level, then you're not going to talk about things at a system level. You're going to talk about, okay, I placed an order. And you can draw the flow of how the different aggregates look like when you model the domain actions, right? So orders would be changed when you place orders, or when you confirm them, their state would change from pending to completed. Reservations would change when you make a reservation, or seats are reserved or orders are confirmed. Payments would change when the payment is made or accepted. So what you can do in building this kind of a model is either think from the edges, which are the actions, and then think about what objects they would update, or think from the objects and say which actions would update them. And so if I was to go back to this diagram here, basically on the right side you saw command and then command handling and then a domain model writing the events. And so all this domain model block here means is that we are looking at domain level commands and domain level events that we are writing in this particular event store. This need not be the case in general for event sourcing. Okay, so that's what domain modeling is about, and that's how it's different from event sourcing. Now let's move on to understanding one last concept with event sourcing. This is called Sagas. So imagine you have a complex system with different departments writing things to your message queue, the event queue. So here you have your messaging system, and all different departments are writing events into this messaging system. The fraud department is writing something, the billing department is writing something, the security department is writing something, that this order looks fake. So all these people and departments and services are writing things, events, into the queue. And those events, when they go in the queue, are being consumed and updating various things. Like, for example, whether, let's say you're eBay and you are taking all these orders, and all these different departments, billing, fraud, warehousing, is saying, okay, did I get the inventory? Do I have it or not? Maybe I don't have the item that the person tried to order. And all of those different departments and complexities can influence whether an actual order should be at the end of the day accepted or not. And if any of them fail, then the order has to go from pending state to failed state rather than from pending to completed. But how do you know when can you go from pending to completed? What if something fails after you said it's completed? So in order to put all of that together and test the order and make sure that it's correct and it's not going to throw the system in a bad state, you have something called a saga. It manages and coordinates these long-running business processes and workflows, and it essentially makes a sequence of actions and event additions atomic. If any of those actions fail, you're essentially going to take the state and revert it to a consistent state, or make sure that you have marked it with certain statuses or messages that allow you to look at the order in a consistent way. So that's what a Saga will do, and we will look at two different ways in which you can build a Saga here. The first one is called choreography-based Saga. And in this case, what happens is that each time a service, let's say the order service here, somebody posted an order, and that posting of the order could trigger a bunch of events, and that can create the order aggregate. The order aggregate is marked as pending, and the order service, once it creates the pending order, will emit an event onto the queue saying that an order has been created. Now, the customer service is looking for orders that get created. It's subscribed to them. And whenever it gets the order created event for a customer, it tries to charge them. Now, if the credit card payment has been reserved, it puts an event on the customer event channel that, hey, we have reserved a credit card. If it fails to reserve a credit card because credit limits exceeded, it's a bad credit card, or whatever other failure cases are, it puts that on the event queue. And if you want to see the customer, you can aggregate the customer, just like from the customer events. Maybe the customer's failed to make payment too many times, and you want to mark the customer as such. And then the order service is reading and looking for customer events for the credit cards, and when an event comes through, it goes ahead and either rejects or approves the order. So order fails or succeeds, completes. So this kind of mechanism where the services need to know about each other and know about each other's events is called choreography-based Saga. Now let's look at another type of Saga here. And this is basically called an orchestration-based Saga. So here we create an orchestrator object which is independent from the details of the given service. And that object basically tells the participants what local transactions to execute. So for example, the order service here receives a post request, creates the Saga, create order Saga orchestrator. The orchestrator then goes and creates the pending state order. That orchestrator sends a reserve credit command to the customer service. So it's basically like, you can think of the orchestrator or the boss sending commands to each applicable service to do the things it needs to do, and putting it all together and saying, okay, the order succeeded or failed. So that's basically orchestration-based Saga as opposed to the choreography-based Saga. And all of these concepts are useful for doing event sourcing, messaging, having a large event-based system, which can scale up and be multi-org and so on and so forth. So that's it for this video. We have gone over numerous concepts like snapshots and playbacks, different ways to create queues. So event queues through CQRS, which I promised. So now you know what it is. It's separating the command, the writing part from the reading part. And you could create queues through sensors or other systems, summarizations through playbacks. Domain modeling and its difference from event sourcing, Sagas. And so thank you. And I hope you enjoyed and learned quite a bit about event sourcing from this video.